prototype designed to domesticate carbon capture. So contemporary urbanism must consider more than just the form of cities because we exploit resources at a global scale. The exploitation of the resources like air, water, energy, and organic materials expands well beyond the physical boundaries of the city. Even with the advancement in technology that has transformed urban protocols, it still largely remains outside the practices of urban planners and architectural designers. Few examples of the exploitation around the world include lithium fields in Bolivia, an example of economic colonization where companies like Tesla are buying acres of land to produce batteries, and tar sands in Canada that is the landscape scale devastation of extraction of oil. Unless the commons are managed, people take advantage of it. Hence, the question that we're addressing in the studio is, can architecture manage resources around it? The purpose of this studio is to activate architecture at a community scale in its engagement with these resources through experimental prototyping and speculative design proposals.
These are a few images of the air pollution. Like if we are focusing on the air aspect of the commons, so these are the images of the global exploitation of air. So in our proposal, we are concentrating on air and in turn air pollution, and the focus is carbon. So the project revolves around the climate emergency that we face globally, where there are articles, discussions, talks, and summits on the vulnerability of air that we breathe. We are specifically focusing on the carbon emissions. Here is a timeline that shows the specific issue. With time, we have been digging out the terrestrial carbon and using it for construction and mobility. This results in an increase in the atmospheric levels. Carbon is an important component in our atmosphere as it maintains a livable temperature. So an increase in the carbon would mean increase in the global temperature. As a result, we explore the new architectural language that is both functional and can be used as a building aesthetic to align with the objective.
Previously, we intervened on the Eastern Development Zone to build an infrastructure that sequesters carbon by installing techniques that capture the carbon and then later convert them into carbon concrete blocks, thus expanding upon the possibility of a new building material. Further, we use the blocks to build an evolving pixelated carbon landscape. Carbon Niwas houses the idea of sequestering carbon at a human level and driving the climate literacy program into the next phase. It houses the possibility of capturing the carbon in the simplest way, making it possible to include in the building code.
Interaction was one of the primary aspects of the proposal, and the prototype is envisioned to flow into different scales and regions through architecture, landscape, and interiors, binding all the scales together. This is a short video on how it is a very interaction-induced prototype. The concept revolves around proposing a central core that would flow through spaces and have an interactive cap around it for human engagement. The tectonics of the junction between organic and the geometric forms became the driving force for both the architectural level and the prototype level proposal.
The system diagram shows how the Arduino controls this engagement with the humans as the prototype senses movement. And this is the system and the core and the cap. The assembly diagram shows how the whole prototype comes together.
So this becomes the interactive cap and this is the core.
So how the system works is, it's a mixture of potassium hydroxide and water. As the bubbling starts, the air molecules are pushed into the core where the CO2 bonds with the potassium hydroxide. This binding isolates the carbon within the core, reducing the ppm levels of the CO2 within the core. The more the people interact, the more the carbon is isolated. We can see this effect better in person, but these are the few images that give an idea of how interaction reduces carbon sequestration. So to demonstrate quickly. Sorry, yeah.
So the engagement is more based on how to involve people in the whole movement of carbon sequestration and introduce a new carbon age. The construction had three components: the system, the interactive cap, and the core that establishes its relationship with light. And to have a contrast, we wanted the core to be central to the whole idea and it to flow through the architecture scale too. So there is a contrast that we're trying to achieve between both the cap and the core. The aim of the texture is to essentially let the core be central to the experience as it will flow to different levels during the boundaries. The carbon capture is a very slow process, and this is the limitation that we came across. It is a very slow process and it requires a more extensive setup to generate effective results. Under the idea to domesticate it, limitations like size and energy make it unable to capture it enough to change the ppm levels of the whole room. So enclosing the central core allows us to reduce the effect of the total capture, making it easy to achieve in a smaller area. These are a few shots of the final product.
So what we've realized so far is carbon sequestration is done at industrial scales. So our ambition is to use architecture as an agency to make people conscious about the presence of carbon and its possibilities to create a carbon economy. Thank you.